Okay, so that's how we've reconstructed paleoclimatology. How do we get modern climatology? Well, for about the last 150 years, we've been getting weather reports. And we take these kind of the old-fashioned way. This is a sling psychrometer. It's got two thermometers on it. One of them has a wick that you wet, that's called the wet bulb, and the other doesn't. We call that the dry bulb. And you take the two temperatures, and from the dry bulb you get the actual atmospheric temperature. From the wet bulb you calculate a wet bulb temperature, which then you can use to calculate humidity or dew point. We use barometers to measure pressure. Sky condition and visibility, the traditional way is a weather observer, a human being, would go out and look at the sky and look at landmarks around to determine how far they can see and what kind of cloud conditions. We measure precipitation by using rain gauges, and we can measure wind velocity. Wind velocity is a vector. That means that there's two parts to it. One is magnitude and the other is direction. So we could say a wind of 10 miles an hour from the northwest. That would be different than a wind of 10 miles an hour from the south. So by combining all these and writing them down, we can take records. And then about 150 years ago, just about the time we started to see the temperatures go up, there was a major breakthrough in communications. And the first people in this country that began taking weather reports and transmitting them was the Army Signal Corps. And they used a couple techniques. One is a heliograph. Anybody know what a heliograph is? Helio means sun. What they actually did was use mirrors, flashing mirrors to send Morse code. And even more importantly, they used a telegraph. And as a matter of fact, about the time of the Great War between the states, in the Smithsonian Institute in Washington, D.C., they used to plot weather from all over the country. Now, that only went about as far west as Missouri and Kansas at that time, because they still didn't have the Intercontinental Railroad. But that was a huge draw. People all over the country went to Washington, D.C. to walk in and see one weather map that had the weather all over the country. And it was because of communications that we were able to do this. Well, we still take these things today, but I know you're all interested in robotics. Instead of having human beings do it, it's all done automatically now. And this stands for Automated Surface Observing System. It's used by the National Weather Service and the military. So if you went out to Hartsfield-Jackson International Airport, somewhere out on the airport, now this is one on the roof of the National Weather Service office, this is one that's out on an airport, you'd see a system like this, and you can see that here's your wind measuring instruments. They've got instruments to measure temperature, humidity, they've got automatic tipping rain gauges, all this kind of stuff is done automatically. It's measured, a computer sends the information over the internet, and it gets to big computers that store all the data. So now it's much more automated. And these weather reports are then, back in the old days, when I first started out as a weather forecaster in the Air Force, we had to sit down and plot all this by hand. Well, now it's all done by computer. And this is actually from the 24th, that was Friday. Yeah, this is actually a weather plot from Friday. You see all these little green dots for rain. Remember Friday was raining here? So the winds are from the east, and it's all plotted automatically by computers, so we don't have to do it by hand anymore. So as a matter of fact, we have a computer here in our computer room, one floor down, and data comes in. Everybody shares it now, and I've got a software program that sits there, runs every hour, plots one of these things up, and makes a GIF file and posts it to a web page. So I can just go to a web page and look it up, and I can see the weather in Georgia, and it's all automated. And here's the same thing for a whole map. Now this again was on Friday, and that was at 600 Coordinated Universal Time. which would be 2 a.m. here, and meteorologists have actually plotted that. So here's that little low pressure system that brought us all in rain on Friday. That's long gone now, and up here is a bunch of real cold air. Now, that was Friday. Now, about Tuesday morning when you get up, it's going to be here. Now, that air has come direct from the Arctic, and when you go out on Tuesday morning to wait for a school bus, wear a jacket. Don't wear shorts and sandals, because it's going to be cold. It's going to be the coldest day you've seen since last winter. Yeah?
What are the blue curved lines?
Those are called fronts. Those are called fronts. They're the boundary layers between the air masses. So here we see warm, moist air that was moving up. You see these wind barbs here, air moving from the northeast. Here we have air moving up across from the south, so you got two different air masses colliding, and they're called fronts. And the reason they're called that was, during World War I, in the newspaper, they didn't have CNN back then, they used to have newspapers, and every day in the newspaper there'd be maps of what was going on in the war. In World War I, the armies didn't move much. They had these things called fronts, and they just shot across them. Well, right after the war, some Norwegian scientists developed a model for the atmosphere that was called the Norwegian wave frontal model, and they borrowed the diagrams that the newspapers used showing the front lines of the war were, and they called them fronts. So that's why we use these same symbols. A little bit of trivia there. Well, in addition to these hourly reports, which tend to support aviation activities, they're mostly taken at airports. So for example, if you looked at that map I had, Dobbins Airport, Falcon Field, and Peachtree City, Charlie Brown Airport, Atlanta, Hartsfield, Jackson, DeKalb, Peachtree, they're all airports. But one problem with airports is that airport environments aren't very much like other environments. How many of you have been to Hartsfield Airport, Hartsfield, Jackson? It's loud, it's all covered with cement and stuff. Well, that makes for different temperatures than, say, if you live in Roswell or Conyers or even downtown Atlanta where we got lots of trees. So it's a little different. And as a matter of fact, when you compare temperatures taken in 1850 to the ones taken now, in 1850 they didn't have any airports. Didn't have any airports until, modern airports really, until the 1930s. The Wright brothers didn't fly until 1903. So you got to be careful comparing temperatures from 1850 to today. Well, there's another thing, and that's the National Weather Service Cooperative Observer Program. And what that is that's an old-fashioned one where people would volunteer to be cooperative observers, and they'd have this instrument shelter in their house or farm, and they'd go out every day and write down the high and low temperature and all this kind of stuff. And now they've got automated ones that do the same thing. Well, one problem is that there's a little bit of controversy in that many of these aren't sited properly. This is out, it's got all grass. Many of them, unfortunately, are in parking lots. There's a guy in California who's got all sorts of pictures, and this has things you want to be careful of in global warming. Is if he's got one picture of one that's sitting right next to an air conditioner. Well, the air conditioner's taking hot air out of the house, and it's pulling onto that, so it's going to give you bad readings. But these are not hourly observations, but they're observations twice a day. And actually, many of these show less warming than do the aviation network thing. So that's something that produces uncertainty. And whenever you're dealing with data, you have to understand uncertainty. You can never measure something exactly. So it's only a question of how much error there is in your observation. So where do we store these data? Well, the National Climatic Data Center. The World Data Center for Meteorology is in Asheville, North Carolina. That's about 3 hours from here. And they've got huge, huge rooms full of computers and things, and they store all the meteorological data. And they also run the World Data Center for Paleoclimatology. That's the stuff that we couldn't directly measure, the stuff that we had to go back and figure on, and that's out in Boulder, Colorado.